what was your initial response to these when you learned about them? And did they freak you out, or have you just kind of been completely kind of taken up by the wonder of them? Just curious. Talk to me a little bit about the experience of it.
So there's the idea of evolution. And evolution doesn't necessarily have the best outcome, but I guess that's the difference between best and outcome. If I'm not mistaken.
You gotta yell it out.
Okay, sorry. So like this is like human evolution, we have vestigial organs and everything, and we don't need. So we're not necessarily the best, but we're optimized for what we have to do in our environment. With genetic algorithms, that's kind of what, yeah. And then I'm gonna let him take over because he knows way more than me. But, so I guess that's just my aspect. So I've always tried to connect that point. That it's not, we're not trying to be the best. We're just trying to make it work well within the environment. So, yeah.
Okay, so I wouldn't even say optimized. I would say sufficient. Because
Sufficient or efficient?
sufficient.
Sufficient.
Because I mean, even if you look at something that's highly evolved or something you consider highly evolved, often it's just sufficient, but not perfect for most cases. It's generally good. It's a generally good solution. So as far as my perspective on it, when I first encountered it, it's a tool, I think. Just as much as recursion is programming. Speaking from a programming perspective. So it's an interesting algorithm to kind of. Or it's an interesting class of algorithms to take advantage of kind of natural organization.
I can see why businesses utilize genetic algorithms, architects or actually insurance companies, where I feel as though genetic algorithms mimic nature. They keep in mind the various independent factors that can happen, yet they work around the solution, so the probability goes to that, just trust that. So as long as the human mind is at ease, the computer is still functioning, it's good for the business.
But where they become interesting is when you start combining them. We talked a couple of weeks ago about neural networks. So imagine combining a genetic algorithm and a neural network, and there's lots of work going on in this at the moment. So we are not only training a neural network to perform some function which we see as intelligent, for example, pattern recognition, to recognize objects. So we're not only training it, we're also evolving multiple neural networks of brains to find the optimum one. So we're mixing these two different technologies. So we're having an evolutionary process on a training process.
You're using the genetic algorithms in place of backpropagation?
No, you're still using the main neural network algorithms, but imagine having 1,000 neural networks which you're training, and then you take those as your population set and evolve those over time. Well, as we gain more processing power, we can start to do things like that. So we're actually evolving the brains as well. So we're training these mini brains and then evolving them over generations to find the optimum neural network training set. So,
Is this training and evolving taking place only in one research center? Would it be autonomous, or are they linked across research centers? Are they networked, I guess is what I'm saying, or is that too complicated?
I don't know all the individual research projects.
I mean, the possibilities here are wonderful and frightening. But wonderful.
Does this have anything to do with how Google gives you search returns back? Because if they're using an algorithm like this, you're giving them queries and they're giving you back information, but it's optimized for you almost, right? Because they keep track of.
That's another class I'm teaching at the moment about. We're going to do some work on personalization of web searches, filterables, things like that. The algorithms they use are advanced pattern matching. I don't know their algorithms that well, but if I had to choose one of the technologies, it's more of a neural network approach that they're learning about you and they're pattern matching those things against a set of criteria rather than evolving you as a consumer. It's more pattern matching. But what they have is they have very large human, I won't say human resource, I'll say marketing people are some of the most frightening people you'll ever meet. The ones who do a lot of this work, because they can look at you and they can tell you things about yourself that you wouldn't think they'd know. They can tell you what kind of shoes you buy, or you buy this breakfast cereal, just by knowing a little bit about how much you earn, the kind of job you have, where you live, and they will suddenly start telling you things. It's like, gee, I do that, you know, and how do they know that? And it's because they know statistically you're very likely to do these things. They'll tell you what kind of beer you drink, what you do. And I've had it done to me a couple of times, and it has freaked me out that they can
Did
predict
you see
something.
the Google Now that they're releasing? That's scary.
Yeah, it gets even worse, believe me. There are...
I don't know what Google Now is with that.
It basically starts giving you information that it thinks you might want based on what it already knows about.
Okay.
So it's almost the idea of, we used to go seek information on the web, and now it's just being brought to us.
But it's also linked to your spatial location, so it knows where you are and what you might. If every Tuesday you go out to a certain shopping centre, you'll start getting their special offers on the Tuesday as you're on your way.
And it knows I go to that shopping center because of what my
On the
credit card.
Tuesday, yeah. It knows where you are, cards you use, everything, yeah.
Because I spend a lot of time here, when I'm visiting a friend on the other side of town, it tells me how long it takes to get back home.
Oh, okay. Tom, you might join.
Yeah, I was wondering, could you apply this to something like defense? Could you maybe, I don't know, in a sort of war games or Skynet sense of, you know, a Whopper or something, can you sort of make a genetic algorithm of, say, this is what Kim Jong-il's son, like, now that he's in power, like, if we were in a super bad conflict or whatever, this is all the possible scenarios.
It's being used for strategic, yes. For wargaming type thing, of course it is, because you can run thousands of possible scenarios and see what different outcomes are and work a way to get to the best outcomes.
We don't have it
Against
working
constraints.
We don't have it playing checkers, do we? Checkers and Falcon's Maze and everything, do we?
Well, they do. I mean, the genetic algorithms are, if you think about chess, for example, the problem with chess is combinatorial explosion, that you have too many possible solutions to predict the best outcome. Because every move has so many other possible moves from it, even the biggest computer in the world can't consider all of the possible moves. Although deep thought looks at more possible moves in 1 second than Kasparov will do in his lifetime. But, and he can still play, Kasparov can still give it a good game against it. But there's so many possible outcomes. But the best thing about genetic algorithms is that search space is so enormous. What genetic algorithms can do is they can have 1,000 searches, if you like, going on because there's so many solutions, and you're jumping around the search space. Most other search engines, traditionally playing chess, you look down one path of making one move and see what happens. These are searching in much bigger space because they're jumping around, breeding solutions. So it works in a very different way. But that's why they're used for those kind of problems, to look at all the possible outcomes of a set of actions.
Are these used to design games?
I'd like to say yes, but in very specific areas. We don't evolve a whole computer game. We're not anywhere near that. But there are research projects in procedural content generation that use genetic algorithms for generating, for example, landscapes, things like that. And, you know,
Why wouldn't we use them to evolve games? It's just too complicated, or?
Yes, I guess so. Yeah, we just, I mean,
Are you
there's no
familiar
reason
with
we
Frank
can't.
Lloyd's-
I mean, there are a lot of genetic algorithms to evolve strategies. There's a research project I know of to evolve a machine that can play Tetris. So, and the interesting thing is, of course, we can program rules into a machine so it can play Tetris and rotate the blocks. But the interesting thing is watching a machine evolve a route. So there's three ways we can do it. So I initially said we have the top-down, bottom-up approach. We can put explicit rules in a machine that tell it how to play Tetris. We can let it learn by repeatedly seeing outcomes and learn like the brain. Or we can evolve a machine that can play Tetris.
Is the outlier effect also studied with this?
What do you mean by outlier?
In other words,
Outlier or outlier?
there will be some, in any of these algorithm results, there will be some things that are at the edges.
Oh, outliers, yeah, absolutely. But so, if you have 1,000 objects, and some have we call it a fitness factor, but say they have a measure of how good they are in this environment, say 10, and you have some that have a measure of 100. The ones that have a measure of 10 aren't automatically going to die. They have a lower probability of surviving, but they may survive. And the reason you want those poor ones to survive is they may have one feature that's really good, even though they have a low overall score. So you still want those to be able to breed with possibly to breed. However, although it's a probabilistic process, although we want the ones who are better fit to the environment to survive, you also want the features of the outliers, as you say. The unusual ones, which is why you have the mutation. A small random mutation that may create something that helps something survive in the environment. You know, the first squirrel to actually get some webbing between its hands that allowed it to jump from tree to tree a little bit better than the squirrel next door.
From a little web to Rocky the Flying Squirrel.
Yeah, so
There was somebody who had a hand up.
He answered the question.
Oh,
In regards to like the next question, like, it's brought up like I don't know whether it's issue now, but the whole ethics of general genetic algorithm. Because if you train and evolve to a certain extent over time in the future, I can see it getting really better. I can see human to be more tolerant of AI-based decisions. So it's like with the ethics of like a war situation or law for that matter, like is that an issue? Because I can see a computer saying, you know, depicting a situation to find the best outcome, but ethically, morally, to humans, it won't be that. But over time, I can see humans, you know, sorry to think radically, but
Well,
come to that.
there's two things here. One, you're not finding the best solution. As Anthony said, you're finding the sufficient solution. The search space is too big in most of these problems, and the genetic algorithm will find a good solution, but not always the optimum or best, because the search space is too big. But secondly, what are we actually evolving here? We are evolving an algorithm. We're evolving a solution to something. We're not evolving a squirrel or something, this idea of, we moved away from consciousness a little bit in this discussion, but that's not what we're evolving. We're evolving a solution. Now, it becomes interesting when we start thinking about this in conjunction with some of the other discussion on intelligent machines. Well, what we're doing now with these things is we're optimizing a washing machine. You know, finding the best design of a drum for a washing machine using this. I think we're a long way from what we would class as evolving intelligence.
Well, that's why I don't really like find the unsettling genetic algorithm. When you say it's kind of creepy, right? And I guess maybe I'm missing something, but I don't really see what's creepy about a genetic algorithm. Maybe there's something I'm not thinking about, but it's an optimization problem.
Oh, sure.
It's a brute force approach.
What's creepy is what it does to my imagination about what might be possible.
It's funny that my PhD in AI was around fuzzy logic. I did some work with neural nets, but immediately after I finished my PhD, I worked for 2 years on a genetic algorithm project, and we were evolving schedules for. It was funded by large engineering. It was funded by all of them. It's large engineering concerns, and what they were interested in was if you have large pieces of equipment that cost $1 million, they cost thousands of dollars a day to run. Where they are positioned, for example, in a mining operation or using certain drilling equipment, how that is run costs thousands of dollars. And if you move it somewhere and move it back, you can lose thousands of dollars. So how do you optimize that process along with the schedule of all the other pieces of equipment and optimize the schedule? And just in a $600 million operation, obviously saving 1% saves you $6 million. So just optimizing that schedule a little bit. So what we did is we built thousands of schedules. And the schedules were like living things. They evolved, they survived, they bred with each other, like the first year of one schedule bred with the second year of another. And, we were breeding time, if you like.
Wow. That's wonderful. I'm going to have to think about that one.
But you're doing more than breeding time. You're breeding 3D spatial and the timing of where things are. And of course, when you're doing things like that, you get all sorts of unfeasible operations. So you have to have something that makes sure the solution is a real solution.
Right.
So, it's an interesting. Funnily enough, the papers I wrote on that are my most cited papers in my whole.
I'm wondering if we could use it to help improve schedules at universities.
Anything would be better than what we've got, but yeah.
So I was wondering, now that I think about it, I'm wondering if this can apply to something that Pat, you and I were talking about in the last class. This idea that I have of teaching a computer, like combining a word parser with something like this to more or less have a computer simulate correctly delivering curse words to something. The great thing about curse words is that it's, if you think about it, as much as, it's filthy language, it's profanity, it's simplistic. Profanity is actually a pretty complex part of linguistics because it's got so many different contexts depending on intonation and use, usage and context. So the way I thought about it is, maybe not quite to the level of the Turing test of if I can have an intelligent conversation with a computer. But if a computer can curse at me and call me something filthy, and I feel like I've been called something filthy based on the correct context of a conversation, if I feel like I've been cursed at by a person, then that should show.
That's another example of the Turing test, but let's open this up a little bit bigger to scare Patrick with something else. So let's take being a Shakespearean scholar, I'm going to throw this one at Patrick. So let's take a Shakespeare play like The Tempest, and let's do something which will probably horrify you and rewrite it.
Well, actually, The Tempest has been rewritten.
Rewritten.
Already.
So let's take different versions of The Tempest, change the ending, put some more action in it, Let's do different versions of it, let's change it, let's have 1,000 of them, let's evaluate those in front of audiences, and then let's evolve them, and evolve a better version of The Tempest. Now,
there's an argument to be made and it's already been made by some Shakespeareans, that's exactly what Shakespeare is doing. So, let me give you a quick example. He writes this play called Romeo and Juliet. It might help if I draw it. Okay, so he writes Romeo and Juliet, And he has these two characters, Romeo and Juliet. And then about the same time, either before or after, or maybe simultaneously, he writes another play called A Midsummer Night's Dream. And instead of just having Romeo and Juliet, he creates two pairs of lovers. So he creates Lysander and Hermia, and Demetrius, and Helena. Same plot. These two are separated by feuding families. In this case, her father, Aegeus, right, wants her to marry this guy, Demetrius. Okay, but these two are really in love with each other. Okay, and this guy, Demetrius, has already betrothed himself privately to her, to Helena. So what Shakespeare's, in a simplistic way, what he's doing in two different plays that he's writing about at the same time, is he's taking something like the same plot structure, the same sort of phrase, young people in love prohibited from marrying, where there's an obstacle, and he's giving us in a different play, basically the same plot, only complicating it with pairs of lovers.
There's an interesting thing I often think in terms of visual art as well. We look at early representations of visual art from cave paintings through different art. Is it an evolutionary process? The same as language and literature, the evolution of the media as well as of ourselves as humans.
I don't have any problem thinking of it as an evolutionary.
So there's evolutionary in a small scale of even one play being rewritten, but over generations of media evolving.
So what Shakespeare critics says, if we had more sophisticated computer models, I think we'd have that would enable us to do something like plot analysis. I think we'd find all kinds of surprises just by using the Shakespeare corpus. One of the things that we do as Shakespeareans, if you've had my English 319 class, I don't think I have a copy of it here. I have it on, I think I have it on a PowerPoint slide. What I do is I divide Shakespeare's career into about 3 to 5 year blocks. So we know that Shakespeare wrote plays that we comfortably classify as history plays, as comedies, and there are different kinds of these things, and tragedies, and we know that he wrote poems of different kinds. So we can simply create a chart, and we can notice it, divide Shakespeare's career up into different stages, and we can see that at one point in his career, if our dating of the plays is more or less right, we can see that basically there's a 3 to 5 year period where all he writes are tragedies. Okay, but that early in his career, for the first 10 years of his career, he writes all these different kinds of plays, histories, comedies, and fewer tragedies. And we kind of know that he was writing fewer tragedies because Christopher Marlowe has arrived, and Marlowe had captured the corner on the writing of tragedy. So there was more demand and more freedom for him as an artist to produce history plays and comedies. When Marlowe dies, then he starts to produce tragedies in greater numbers.
I'm interested in this idea, though,
Let me see if I can show you.
I'm interested in this rewriting idea of something evolving.
Yeah,
You know?
yeah. Well, Shakespeare's own career is evolving, right? His consciousness, his knowledge, his skill as a writer is developing over time, right? And he's drawing on, his reading, on cultural and social material, but he's also drawing on his own experience of aging, of being a father, of having a son die, of having a father die. So life is informing Shakespeare's writing, just as his writing is kind of informing life. Can I throw this in here?
Of course, yeah. Just press escape.
Okay.
Close it again. Oh, the one other thing I put on the canvas is there is a PDF there's a full textbook available online on genetic algorithms. Obviously, don't expect to read the full textbook, but if you are interested, there's great introduction section. It's up on canvas.
Oh, I always run into this problem. Let's see here. Here it is. I'm not sure how well you'll be able to see this. But, so this is more or less everything that Shakespeare wrote that we have, that exists. And so we can break it out in terms of genres. Now these are arbitrary categories, obviously. For example, a lot of people might think that Richard III up here could be classified as a tragedy, right? But it's he's recently been in the news because they found his skeleton under a parking lot. But you can see that right over here, this period of his life, he's just concentrating on tragedies. Now, if you want, I can show you some weird things. Okay, but this won't be a Shakespeare lecture. I think this will be. Is there an eraser here somewhere? Is this okay? Are there things you wanted to?
No.
Let me see if I can show you some of the potential ways, and we might want to experiment with this in this class if you're up for it. There's some potential ways in which we can think about how narratives are generated. So there was a movement called structuralism. It's the people that invented this thing that we call structuralism. Were followers of Ferdinand de Saussure. And Saussure's teachers were fascinated by Darwin. Okay? So the emergence of this thing that we call structural linguistics is actually a response to Darwinism.
But Saussure also was one of the founders of semiotics.
Yes, and that's where I'm going.
Okay.
That's where I'm headed here. Okay? Now, what's the fundamental insight of Saussurean linguistics? There are a couple of them. One is that language, whatever we mean by language, right? Keep it open. That language is constituted by differences in which there are no positive terms. So what does this mean? That the only way we can tell an A from an E is that E is different than A. And the same thing with an I and an O and a U. That the only thing that makes the I an I is that it's not an E or an O. Does that make any sense? So this is what we mean by a system of differences without positive terms. So far, so good. So the same principle applies to words. So pat, hit, pot, and put. Right? These come to have differences of meaning and so on, different kinds of uses, but essentially all we have here is a system. It's an arbitrary system, but it's been in play, so it's motivated. It has real effects. It gets focused. It has a real history to it.
Those who've done my intro class, what is this reminding you of? Definitions. Something that can only be defined.
Color.
It's called what in here?
Color. The definition of color is that if you put two objects next to each other, and they're the same, they look exactly the same except something's different, it's color.
Yeah, so if they are the same size, the same shape, the same weight, the same properties, everything's the same, but they're still different, then they're different colours. There's no other way to define
You just
colour.
use the word color.
You're
talking
that is
specifically
the
about
dictionary
color.
definition of colour.
Of color, yes.
Is that when you have
works.
two,
Yeah.
So it's very
exactly
similar. The only way to define something when you have no positive term is the difference between it. It's colour.
It's in the system.
It's the same definition we use for colour.
Beautiful. That's perfect.
Yeah.
Okay. So now let's extend this out. Did you have a question?
No, I was thinking about how that affects the woman in the white room thought experiment from a few classes ago. So in that thought experiment, we defined color in terms of its wavelength and its properties and what neural pathways it lights up in your brain. We didn't really talk about that at all. But I feel like that definition of color would have a drastically different effect on the woman in the white room.
Yeah.
than the science.
Because colours is experienced as a subjective experience.
Oh, right. It does. Okay.
Yeah.
So now
it's
let's extend this the next step. Okay. So you can apply this to chess and so on. Chess is just what separates a rook from a knight, a king from a queen, right? It's their place in this system of differences. Is that working for you? Now let's see if we can extend this out a little bit. In narrative theory, we sometimes distinguish between three levels of a narrative. You have something like the surface narrative, where just the words as you're reading along, hearing the story, or reading the story, hearing it with your ear, or seeing it with your eye, or a little bit of both. Okay. Sometimes we'll just call that the surface structure. And then we say that the surface structure is created through something that we eventually, some people call a narrative grammar. And the narrative grammar is basically a simple syntactical structure. So you have a sender and an object that gets sent and some kind of a receiver. So the queen sends the knight out to rescue the villagers from the dragon or something. Okay? So there's a mission. So what we have here is a simple, and you can complicate this in many different kind of syntactical ways, but we'll call this level that is necessary to produce the surface text a narrative grammar. Okay? Is that working for you?
Just the phrasing of grammar. It's
Yeah,
not about sentence structure, it's about overall grammar of
Right, it's more about things like syntax and so on. It might begin to make a little bit more sense when I get to the third level. Sometimes the third level is mistakenly called deep structure. It's a complicated term, everybody abuses it in casual speech and narrative theory when we're doing just kind of practical criticism. So but the idea is that there's something down here that I'm going to call the semiotic square. Or it's sometimes called the semiotic rectangle. And it's a series of these, sometimes it could be just one, but it's a series of these semiotic squares that drive the narrative grammar, so to speak. And it's the narrative grammar that gets manifested at the surface level. Now this might not make a lot of sense right now. It's just a general picture if we're trying to think about, trying to answer a couple of questions that preoccupy narrative theorists. One of the questions that preoccupies narrative theory is, why do we have this incessant, kind of unceasing drive to hear lots and lots of stories? Why do we always want to hear yet another story, and another story, and another story? And why do we produce so many of them? While at the same time, what we often really, when we sort of really start to think about these narratives, a lot of them seem to be the same story. Right? So it's really easy to kind of start to say, well, that's the same story that Boccaccio told, that Shakespeare told. Why do we keep retelling the story of the Oedipus struggles, where a son kills his father and he does something like the equivalent of sleeping with or marrying his mother? Okay? Why does that story keep repeating in culture after culture, in historical period after historical period? Tom, you have a question?
Yeah, so to that end, to hearing the same story over and over again, are you basically saying that if you wanted to, could you combine something like a genetic algorithm with Joseph Campbell's stuff and essentially get like, take world mythologies and basically dwindle it down to like, evolve, like dilute a story down to like, bare bones, one could, or I guess, like, could you combine something like Joseph Campbell's work with a genetic algorithm and get something out of that, I guess?
I think I have something here that might help. Were you going to say something, Dan?
I was going to say, to my mind, Joseph Campbell has already distilled the essence out of the story. That's what he's done. He's taken that essence out, the archetypes that are there.
Here's Campbell's model for those of you who don't know it. It's based on a simple structure. I'm lifting this from Campbell's book, Hero with a Thousand Faces, which wasn't his major work. His major work
is the most famous,
called The Masks of God. So this is kind of a popularization that Campbell wrote based on years of doing comparative mythological work. Okay, the idea is that the hero in any narrative leaves home and crosses some kind of a threshold, undergoes certain kinds of trials and adventures, and then down here the hero could be killed off and the journey comes to an end, or the hero could continue to have victory after victory and gain in power and abilities, acquire treasure, better swords, better poisons, right? At some point the hero, if he's successful or she's successful, returns back to this upper world and returns home and brings back some kind of a gift or a solution to the society from which the hero has initially set forth. So if you wanted to, this is lifted right from Campbell. I think it's legible, isn't it? This is basically taken right from the Hero with a Thousand Faces.
This is a reductive way of thinking about narratives because it reduces every story to the same story.
The funny
Okay.
thing is, think of every movie you've ever seen and you kind of fit in.
Yeah, so it's a very powerful explanatory tool that's based on a pre-structuralist understanding of language. So the people that do structuralism that I'm talking about in the other scenario, the people who do structuralism are working, this is the PowerPoint slide that I was drawing on the board a second ago. Okay, where the red line is the surface structure of the narrative. The boxes here are the narrative grammar, where you take something and you kind of form something like sentences. Once upon a time, there was a boy who met a dragon, right? And they smoked dope together or something. So, so what you have down here is you have a binary opposition that's driving that narrative grammar. So you have a boy and a dragon, a human and an animal. So the story is actually trying to resolve the tension between these irreconcilable differences. In other words, the insight of structuralism, if you go back to the diagram I had up here a minute ago, where we have words that are just, and letters are just systems of differences without any positive terms, remember that? What structures these semiotic squares, I'm going to give you a different map for this in a second. What structures these semiotic squares are irreconcilable differences where there are no positive terms. Is that working for you? Just,
Reconcile
Yeah.
the difference between like characters in the story or like entities in the story, or
It could be characters, it could just be sounds. Once upon a time there was the sound A, and it was not the sound B, but B and A got together and they formed an ab. They had 6 abs and they were a six-pack.
that's what's meant by the semiotic square. Then
Huh?
that's what's meant by the semiotic square.
Yeah, let me show you the semiotic square, okay? Yeah, sorry. So I think I have, let's see if I have an abstract version of the semiotic. I do have one here, okay. This is essentially the Gramscian semiotic square, where you have, just posit any one particular unit of meaning, and then you can imagine the absence of that unit of meaning. You can imagine its opposite, right, and the absence of its opposite. Okay, so from one unit of meaning, boy and dragon, right, A and B, from any term that only is what it is because it's not the other terms in the system, you can generate at least 3 other positions. And in fact, you can begin to imagine a position midway between S1 and S2, between S2 and negative S1. So you can begin to do what Fred Jameson calls circling the square. Yes, Tom?
So essentially, something like that, something like all of this combined with sort of a technological, you could have a story, you could have a computer or a robot or what have you write its own story of some kind of narrative in some cohesive way by breaking down all of those stories and applying it to different names.
Yeah, I get it. I think what you're suggesting is potentially the case, based on what Damien's been telling us about genetic algorithms. But I think we're jumping, we're making great leaps here of the imagination. What's really on the ground possible right now, I don't know.
The way you explain the whole, literally is literary algorithm, where you explain it, so I also think about like phrase type scripture also, like it was five mass, like that's how the story is going to be structured. But it's like, back to your question, you said Bible, human, like man yearns for storytelling, and what do you think is for the interpretation? And I think
I lost it.
for the interpretation, because I feel as though, yes, you can come up with all these different stories that have the same archetype, same structure, but each person, each reader is going to interpret it differently. So when you
Not exactly.
well, when you mean
Here's hold that thought though. Where this actually goes, and it would take a little bit of lecturing to prove it to you, but where your observation is actually going, it goes something like this. When you are looking at the surface narrative of a text, I can more or less predict, right, that somebody's going to zero in on some semiotic aspect of that text. So I might not know who in this room will respond to the text in a particular way, but I can sketch out what the available, what the probable interpretations of the text will be. So without actually having critics go out there and produce a criticism of a work, we could write a work, okay, and we could theoretically describe every possible interpretive position that people are likely to take regarding that work. This insight frightens people who are literary critics because they think, you mean there's nothing original about what it is that I do? And my answer is yes.
This is achieved, this prediction of interpretation is achieved by distilling it down to the semiotic level, semiotic squares. It's like this prediction of other people's reactions to the work is achieved by distilling the story down to the semiotic squares.
Right. And then building it back up. Yeah. Let me show you quickly how this works, and I think you'll start to see it when we put in some other kind of words here. Okay. Let me see. Oh, that's where it ends. Levi-Strauss, Claude Levi-Strauss. Oh, here. Why don't you ask your question first, and then because we want to give a little time to talk about the assignment right here.
So, kind of a definition question. When you're referencing the squares, you're saying differences without positive terms?
Right.
What's the definition of positive term?
Something that has like a sense, reference, and a meaning attached to it.
So just meaning at all, but not necessarily?
Yeah, meaning is something that happens down the road. So there's no meaning to red or blue. It's just that red is not blue and blue is not red.
And this is in the comparison between squares?
Yeah, so back to the initial slide, S1 is not S2. S2 is the opposite of S1. Negative S1 is the absence of S1. And let me show you how that works here. So Levi-Strauss took the insight of Saussure, okay, that language is just a system of arbitrary differences without positive terms. Levi-Strauss was a cultural anthropologist. He said, what if we take that insight and instead of applying it to language, apply it to cultures and societies? And so one of Claude Levi-Strauss's most important insights was what you have on this scheme. He uses the semiotic structure, okay, to talk about how cultures and societies are organized. So he says every society organizes itself around, if you want to belong, you have to do these things. And if you do these other things, you're not one of us, okay? But then sometimes in societies, you have to have permission to do something, and other times you have the option of doing it with or without permission. Is that making some sense? So if you just think about the first line there, the prescription prohibition line, right? And think about the quickest way into this is to think about the debate that we're having in our country right now about gay marriage, okay? Because we don't have just any one of these. It's not like only one semiotic system is operating at any time. So Remus wrote a little essay called The Interaction of Semiotic Constraints. And he says, let's just think about a marriage. So we have a semiotic square for what the culture says marriage ought to be. In our traditional society, right, it's the prescription, men marry women, women marry men, right? Fathers don't marry their daughters, daughters don't marry their brothers, okay? So if you do those things that are prohibited, you're not part of the group, okay? Or you don't have those options of marriage available to you in this particular society, okay? So that's what the culture says. Now let's imagine a different semiotic system that interacts with this one, right? So, but I won't overlap it right now, about my personal values. So let's say I'm attracted to men and I want to marry a man, okay? Then my personal semiotic system is saying, I have to marry. In order for me to be me, I've got to marry guys. I want to marry guys. But the culture is saying I can't. So what you see there is these semiotic systems are interacting, but they're interacting in a way that causes friction, that causes anxiety. And in order to resolve that friction or anxiety, I might want to tell a story about it. So the surface narrative, right, is an attempt to resolve the contradictions within these semiotic systems. Now let's just imagine a third semiotic system that interacts with the cultural system and the personal system. Let's call it an economic one. So there are certain things that are going to be profitable, and there are certain things that are going to lead to a loss. So if I'm in this situation, I might decide that I'm going to marry a woman, right? So that because it's economically beneficial, even though it goes against my personal values. So the meaning of that particular marriage, right, is, you know, this is a disguise, this is a hypocrisy, this is just getting along because the society is too intolerable, whatever kind of story you want to tell about that. But see, I can predict who will say marriage is an atrocity because he should never have gotten married. And I can predict who's like, oh yeah, well, if they both agreed to it, why not? If the culture is hypocritical. So you can see, I can imagine many different kinds of critical responses to this particular narrative, right? Does that make some sense? I might not know who would hold which position, right? But I can basically predict what those positions, those interpretive positions would be. Is this working for you a little bit? So the key here is to think about the interaction of different semiotic systems. These are the three that A.J. Greenhouse uses to talk about the semiotic interactions within a marriage.
You see, I've read where systems are broken down based on a kind of biological, social, and intellectual tensions, that we have biological imperatives, or a narrative, for example, can be broken down that someone had almost motivations, it's biological, there's social constraints and cultural constraints, so it's almost levels. And then we have a personal, intellectual level where we make a decision regarding those. And so I can see, this seems to me a different way of thinking about it in those terms.
Sure.
Where I've heard it described.
You can build some kind of various hierarchies if you want. If you want to privilege, say, biological motivation over, say, a person's own desires. If you want to say that somehow there's something more fundamental that's driving human behavior, like it's more like instinct or something, and we just fool ourselves into thinking that we have some say in the matter. I mean, you could come up with different kinds of hierarchies here. That's, I think, would be an argument or a discussion to have on other issues. But now what Levi-Strauss did with this is he said, okay, imagine that you're an cultural anthropologist and you wander into a pre-literate group of people in an Amazon forest somewhere, which he often did, and you hear them telling stories about wicked stepmothers or wicked mothers-in-law. Does it mean that every mother-in-law in that society is wicked? It doesn't, obviously. So what he said is we can create these semiotic systems to talk about the cultural practices that are occurring in any particular society. But similarly, we can create similar maps, if you will, of the stories that people tell about marriages and mothers-in-law and stepsons and stepdaughters. Are you following me? And then what we can do is we can map the homologies between the stories that people tell in a society with the way in which their social practices, and we can see what kind of stories they're telling about their own social practices. So the semiotic structure enables us to do cultural analysis and sociological analysis, but it also enables us to do literary analysis as well. And we can talk again about the interactions among those different systems. So if we had complex enough computer modeling where we could break these things down, I think we could generate all kinds of potential insights using genetic algorithms and potential.
Well, you've got me thinking already. I hate to break.
I mean, we're working without a net, so I'm learning this stuff as we're talking about it.
This is fascinating to me from purely the things we've been talking about with the new digital humanities area we're going into. I would like to actually have a go at this, breaking narratives down into fundamental components, getting you to break them down, and then using computer models to rebuild them in different ways, or maybe evolve them.
Now, there's an